All right, it's working, I guess. All right, so hi, this is me, Ravan Raman, and welcome to R2E. Last time we talked about the differential equations, their importance, and the kinds of differential equations. So we said we have two kinds of differential equation. One is PDEs, the other one is ODEs. So PDEs are partial differential equations. This one, PDEs is partial differential equations, and ODEs are ordinary differential equation. Uh, okay, I got some problem. Yeah, so what we will be mainly talking about right now in the first part of the series is how to solve ODEs. So my first topic will be ordinary differential equations, right? My first topic will be ordinary differential equations. So what it means when I say ordinary differential equations. So well, if I have a equation of the form, let me change the color first. So if I have a differential equation of the form f that is a function of x, y of x, y dash of x, and so on, y n of x, where n is the nth derivative of the of y, then it's called a differential equation. So where x is the independent sorry, x is the independent variable, and y of x is the dependent no, dependent function. So y of x is a kind of a function, or you can say it's kind of something that you want to find. So y of x will turn out to be some sort of thing like it can somehow to be sine x or cosine x, and you can see, so y is dependent on x. That's what I wanted to say. Uh, Next is we will talk about a few more things. Let's have some examples of differential equations, of ordinary differential equations. So if you see something like ax dy upon dx plus, sorry, bx times y equal to 0. Well, this looks like something of the form fx y dash, sorry, fx y dash comma y equal to 0. So it's an ODE, it's an ODE, and well, to be more precise, it's a linear ODE of degree 1. So I used a couple of words, linear and degree 1, and also order 1. So let's try to dig into these words, what these words mean. So first of all, I'll talk about what we call as order of an ODE. So order of a differential equation is the highest. It is the highest derivative present in the DE. So let's say I have this differential equation ax y double dash of x plus bx y dash of x plus cx y of x equals to 0. So here I can see that the highest power derivative is 2. So I will say it's a second order. Say it's a second order DE. It's a second order differential equation. And yeah, it's a second order differential equation. And the next thing I will tell you about is the degree of the, we'll talk about the degree of the differential equation. So what the degree of the differential equation, just a second. Okay, yeah. So what the degree of the differential equation means is the power of the highest the highest highest derivative. Let's say you have y double dash whole squared plus y of x equals to 0. So in this differential equation, it's a second order differential equation. It's a second order ODE, and the power is 2. So I'll say it's of second degree. It's of second degree, right? So this is the idea of degree. So if I write a differential equation, let's write a general form of differential equation, that is an of x dn on dx to the power n a naught. It's of the zero derivative, so y of x equals to 0. So this is a general form of a differential equation of order m, right? And now if I do this one small little thing down there, and if I say m, so this is an ODE of nth order and mth degree. So this is an ODE of nth order and nth degree. And if m equals to 1, then it is called, sorry, and it's called linear differential equation, right? So this power m goes to 1, then it's called a linear differential equation. All right, so you can say that m is the measure of non-linearity of the ODE. So it's actually the measure of the non-linearity of the ODE, how non-linear your differential equation is, right? Let's move ahead. So in this course we'll study a lot of things. We will study mainly solving the differential equation of the first order and the second order. It is precisely our goal, and I mean we can also solve. I'll also talk about how to solve nth degree ODE. I mean, and that's for a very special case. We'll talk about a very special case when we'll say that we can solve nth degree ODE. All right. So yeah. So let's not wait up more, and let's move ahead with the very first problem of how to solve first order differential equation. Let's try this. So yeah. Okay. Second, to solve first order differential equation. So I got a general form of a differential equation, that is uh, y dash of x plus u of x y of x equals to some R of x, right? That's a very general form of a differential equation. Now, this ODE is called homogeneous if Rx equals to 0, right? So if Rx goes to 0, then yes, this is an ordinary differential equation, and well, the solution turns out to be pretty simple. Then it's just dy upon dx. Sorry, I'm doing, sorry. That will be just dy upon dx, that is equals to minus of ux y of x, and it will go as a, right, dy upon, sorry, dy upon y equals to minus of u of x dfx integral. So there, I will do an indefinite integral here, so that gives me ln of y. I mean, okay, fine. Let's not do it like this. So minus of u of x. Okay, let's take the negative sign outside first. Minus of u of x dx plus c, right? So y goes as a exponential of minus of ux dx. So this is precisely the solution of the differential equation when it's homogeneous. So that's one solution. Now let's, if r of x is not equal to 0, what about that case? Let's talk about that case. So that goes as y dash of x plus u of x y of x equals to r of x. So okay, well, in this scenario I'll use a trick. That my trick is simply uh, I'll multiply the both sides. Let's say this is equation 1. So I say equation 1 multiplied by e to the power exponential, sorry, e to the power integral ux dx. So that goes as e to the power ux dx y dash of x plus ux y dash of x e to the power integral ux dx equals to r e to the power integral ux dx, right? So that this guy forms this form that will take up a form like d by dx of e to the power u dx, so x. Now it's your job to satisfy ourselves that this indeed forms this. All right, so it goes as e to the power integral u dx y of x equals to r e to the power integral u dx integral, and definitely I should put a constant here, a, that goes as y of x equals to a to the power, I think that's the right solution if I'm not wrong, yeah, to the power minus of integral, no, there will not be any a, sorry. So yeah, e to the power minus integral u dx integral r e to the power integral dx. So here, I mean, I want you guys to remember that u is actually u is a function of x, and r is also a function of x. So, r is also defined as a function of x. Now, in the next video, we'll do an example over this because, or okay, all right, we will do the example in this video only. All right, so let's try out one example over this what we have done right here. So let's try out an example. Let's try out an example. So yeah, example. All right. So say I have this differential equation that is y dash of x plus y of x over x equals to sine of x. So my first job is actually to find my integrating factor mu, that is defined as exponential of integral dx. So my u of x is actually 1 over x. Change the color. So my mu turns out to be exponential of dx over x integral, and that goes as exponential of 1 of x, and that is just simply x, right? So yeah, so that goes as x y dash of x plus y of x equals to x sine x. Now it will turn out to be d upon dx of x of y of x, that is x sine of x. So this implies that x y dash of x is actually integral x sine x dx. So that goes as x y dash of x is actually equals to, so we'll use integration by parts here. Okay, so let me move this a little aside. Let me do a little rough work on it here. I'll do a little rough work out here. That goes as, so it's like u, okay, fine, whatever the color is, x sine x dx. So I all right, so I take this thing as my dv, and this thing as u. So goes as x cos x, well, minus of integral uh, cos x dx. And okay, so okay, just let me think of thing. So my sign is correct, so cos derivative is minus sin x, so there should be plus right here, right? So this thing will go as, this will go as minus, and just let me know in the comments if there is a mistake in the sign. I'll correct it. Minus x cos x, and that is minus sin x. So the whole solution, so this thing over here will become minus x cos x minus of sin x. This implies that, sorry, this is not y dash of x, I'm sorry about it. It's not y dash of x, it's y of x. So y of x becomes minus of cos x minus of sin x over x. So this is it precisely. So with this, I talked about the solution. I mean, so if you look at this way, if you look at these things, this is a solution of first order. This is, I mean, from here you can get the solution of first order linear differential equations, and this method was called finding the integration factor. So that's it for today. See you in the next video. Bye.